Okay, so let's assume you have proficiently and quickly done all the air conduction testing at all the thresholds you needed to and charted the results on the audiogram. What do they mean? How do we classify them? So the first thing you're going to look for is pure tone average. And pure tone average is the mathematical average, or the mean, of the air conduction thresholds at 500, 1000, and 2000 hertz for each ear. So essentially you're going to have a left ear PTA and a right ear PTA. And the PTA gives you some basic indication of the patient's overall hearing acuity in the speech range. It's also going to become important later as a cross-check when we talk about speech testing. In some cases, you may see a Fletcher average used instead of a pure tone average, but not that often. The Fletcher average is when only 2 out of 3 of the frequencies are used, so either 500 and 1000 or 1000 and 2000. And typically, it's only done in cases where the hearing loss drops off really suddenly, or one of those 3 thresholds is much worse or much better than the other ones. When you describe hearing loss, when you're talking about hearing loss or writing a report or even counseling a patient, the description of the hearing loss should include type of hearing loss. And that one we're not going to talk about now. We're going to talk about that next week when we talk about bone conduction results. But the hearing loss description should also include degree of hearing loss. And when we describe the degree of hearing loss, we typically describe it from left to right across the audiogram based on the degree of hearing loss that best and worst thresholds fall into. And we'll look at some examples of this in just a minute. And then you're also going to include configuration. So configuration describes the overall shape of the hearing loss. And typical configurations are rising, sloping, flat, cookie bite, reverse cookie bite, precipitously sloping, etc. And we'll look at examples for this too. So, for degree of hearing loss, you're going to describe each ear individually. If the degree is the same for both ears, if the hearing loss is symmetrical, you can group them together. And you're going to describe degree of best air conduction to degree of worst air conduction. So, patient X has a mild to moderate hearing loss in his right ear, or patient X has a severe to profound hearing loss bilaterally. You're going to comment on whether or not it's symmetrical. We're going to ignore this for the moment because we're not talking about bone conduction thresholds. So, degrees of hearing loss. And we're going to talk about this and some more in just a minute. For my purposes, for this class, and there are several different ways to classify degrees of hearing loss. This is what I have come across the most, but be aware that these are subject to, there are other versions of the scale as well. So, for the most part, people can agree that 25 to 40 dB is the mild hearing loss range, 41 to 55 is moderate, 56 to 70 is the moderately severe hearing loss range, 71 to 90 dB is severe hearing loss, and anything above 90 dB HL is a profound hearing loss. Now, the limits of normal hearing are where it starts to break down a little bit. Historically, normal hearing has been from negative 10 to 25 dB. And probably for adults, that's still what you're going to see largely used. For children, normal hearing is really now considered between negative 10 to 15 dB, and the area between 15 and 25 is slight hearing loss. And that's because children are learning so much through listening that even thresholds that are in the 15 to 25 dB range are not clear enough or intense enough for them to learn at full capacity. So for kids, even thresholds in the slight hearing loss range have been shown to have an impact. This is a table from your book. I just blew it up here for you. And this is showing you the different classifications. So the classification that I was using is really based on the Goodman scale from 1965. The Northern and Downs book from 2002 is a pediatrics book. And so this is what you'll see for pediatrics. And then there's the Jerger and Jerger classification from 1980, which I found to be the least used of all of these. In terms of configuration, so this is how your book defines configuration, and these are FIND guidelines to use. A flat hearing loss is, pretty self-explanatory. You can have a gradually sloping, sharply sloping, precipitously sloping. A rising hearing loss goes up from left to right. I don't tend to see peaked and trough actually used in descriptions. I think cookie bite is more of what you'll see written. But again, let me show you some examples of all of these. And then a notched audiogram is pretty self-explanatory once you see what it looks like. So a flat audiogram looks like this, where, there's very little change from octave to octave. There's no big change. If you look at it across, all the thresholds are roughly in the same area. So these are both right ears. And if you look at degree, all the thresholds in this first one on your left are between 50 and 55, which would put them in the moderate hearing loss range. So you could say this person has a flat moderate hearing loss in their right ear. If we look at this one to the right, thresholds are between 35 and 45. So strictly speaking, that actually crosses the boundary from mild hearing loss at 40. So there's a couple of ways you can describe this. You could describe it as a mild to moderate flat hearing loss. There's only one threshold here that's in the moderate range, so if you said something like mainly mild hearing loss, that would be okay too. A gradually sloping hearing loss looks like this. It's dropping or sloping from left to right, and actually when you look at this one on your left, really the left ear is a better example of a gradual slope, where it's going down 5 or maybe 10 dB every octave. So you see that it's not flat, but it's a pretty gradual slope. And same thing over here. So you're going to describe from best to worst. If we look at the left ear on this audiogram that says type 2 on it, if we look at the left ear, you could describe this as a mild to severe hearing loss or mild to moderately severe, gradually sloping hearing loss. And over here you would say this person has a mild to, probably I would say a mild to moderately severe hearing loss bilaterally. These are different examples of precipitously sloping. So sometimes what you see is relatively flat, usually pretty good thresholds, and then a sudden drop, where the hearing loss changes really steeply from one octave to the next octave or to an interoctave. And so you see it here, you see it here, and you can see it up here as well. So this would be the definition of a precipitous slope. And sometimes you'll hear these called ski slope hearing losses. That's sort of older terminology. But you see this as well sometimes. So gradually sloping and precipitously sloping are easy to identify. Sharply or steeply sloping is essentially somewhere in the middle. Okay, so it's not gradual, but it's not a ski slope where it's flat and then all of a sudden it drops. So these are a couple of different examples where you might say the hearing loss is steeply sloping or sharply sloping hearing loss. A rising hearing loss is poorer in the low frequencies, and then it gets better as the frequencies get higher. And this is one of these configurations where you can look at the configuration and look at the shape of the audiogram and know there's only a certain amount of things that are going to cause, in terms of etiology, that are going to cause a hearing loss to look like this. But so rising from left to right. And then a notch. A notch looks like this, where you get a slope and the hearing is bad at one frequency or two frequencies, and then it rebounds and gets better. And if you look at all of these, and you would describe this by saying, if I look at this one over here on the left, I would describe this hearing loss as normal hearing through 2000 hertz, followed by a moderately severe notch, and recovery to mild hearing loss, or something along those lines. If you look at all of these different examples that I pulled from all different places, you'll notice that the notch is at 3,000 or 4,000 hertz for all of them. And that's really, really common. This is a really common pattern of hearing loss for noise-induced hearing loss. You almost always see a notch at 3,000 hertz or 4,000 hertz when you have noise-induced hearing loss. And occasionally you'll see other types of notches, but this notch at 3 or 4K is almost always, and sometimes you'll even see that in the description. A noise notch at 3,000 hertz or 4,000 hertz, or notch at 4,000 hertz, likely noise-induced. These are trough or cookie bite hearing losses, where the hearing is better at either end, and in the middle it looks like a little trough. Or I guess it looks like you just took a bite out of a cookie. Cookie bite is, again, sort of older terminology, but still used. And it's still terminology that I use in writing reports as well. Your book calls this a trough hearing loss. And then a saucer is this same hearing loss but flipped upside down. Looks like an upside down saucer to me, but again, that's neither here nor there. So again, the saucer would look like this flipped over, and sometimes again you'll see that called reverse cookie bite in terms of shape and configuration of the audiogram. So by now, at this point, you should be able to look at an audiogram that has pure tone air conduction thresholds marked on it, calculate pure tone average, classify the degree of hearing loss, describe it in terms of degree from best to worst, and also describe the configuration of the hearing loss. That's where, after the slides, that's where you should really be at this point.